All right, so let's look at this. Guys, I'm going to do, throw some intervals. This will be A, this will be B, this will be C, and I'm going to make a function, f of x. Let's go purple, and let's say,
Good selection.
here's my function, and there it is. And this f of x is going to represent my velocity. So actually it's not going to be f of x, it's going to be v of t. Which means this is my velocity and this right here is my time. Right down here. All right. No number. I'm just talking concepts right here, guys. So this is a graph of my velocity. Now, I want you to think about area under the curve right now. If we look at the area under the curve, so integral from A to B, it's going to be this area right here, right? So integral from A to B, this is a definite integral, that's area under the curve, integral from A to B of v of t dt. When we get area of a rectangle, we do length times width, right?
Yeah.
So to get this area, it's sort of like time times the height of your velocity, except we do all the individuals. We know how we do definite integrals. You take all the individual heights, but they each have an infinitely small width, and etc. That's how you get the area under the curve. Does that sort of make sense? Mm-hmm. So the concept is, if it's time times velocity, that's going to help us with our units right here. So let's take a moment and stop. Let's say velocity is going to be in feet per second, okay? This is very important that you guys understand units. Then time would be in what? Seconds. Great. So this area right here, this area would be seconds is our width and our height is feet per seconds, right? So feet per second times second, it's really second over 1, right?
When those cross each other out.
So these cross each other out,
Feet.
so you just get feet. So
Do you need divided by?
let me write this so it's easier to see.
When you multiply velocity times time, then you see your acceleration.
If you divide velocity by time, you get. We'll talk about that in a second.
Oh, okay.
That's not the right color at all. Okay, so feet per second is our velocity times seconds, and that crosses out, and that gets you feet. So
That's when you do integrals.
that's when you do integral.
Oh, so it's just like making a position graph. Right? 'Cause
Sort of. If you
goes
integrate
from
velocity, you get position.
Velocity to
Similar.
acceleration.
Yeah, you're definitely on the right track. So let's talk about this. If you integrate velocity over an interval, you get basically your distance, right?
Yeah.
I'm going to say displacement. So if you integrate velocity over an interval, you get your displacement. Notice, this is how fast we were traveling. We were traveling in the positive direction, right? If we integrate that over time, we're going to know how far we traveled, how many feet we traveled in total. Does that make sense, guys?
Yes.
Okay, now, wait. If we integrated velocity over this interval, and this right here would be a positive area, correct? This right here would be a
Negative.
So the reason I say it gives you displacement is because we would move, maybe this has an area, we'll say, of 8 units. 8 units squared. And this has an area of, say, 1 unit squared.
7.
So we would be displaced 7 units. And let me talk about how. Because I would end up going forward 8 blocks, right? Forward 8 blocks, but then I go back 1 block. So how far am I from where I start? I'm actually only 7 units from where I start. Does that make sense? Okay. So in this particular case, integral from A to B of v of t dt is going to be 8, because integral from A to B is 8 units. Does that sort of make sense, guys?
Yeah.
Now, what would be the integral from A to C? What's that equal to? 7, right? I'm going to do 2 different integrals here, so we really have to understand this. So integral from A to C of v of t dt is going to be 8 minus 1, which equals 7 units. And it's actually, our units are feet, so we can really say feet. And this is going to be feet. Now,
Why don't you wait? Why don't you do a B to C?
if I did B to C, that would be -1. Because I went backwards one foot. So the area under the curve from A to B is 8. The area under the curve from B to C, I'm saying, is 1, okay?
Why is it
-1, you're absolutely correct. You're right.
so technically, okay.
I'm saying this area is 1 unit squared, but if you integrated over B to C, you get -1. It's beneath the x-axis. Yes?
If it was a positive number, it would be added to the 8, right?
Yeah, so if this was above the x-axis.
Okay.
So now let's look at this, guys. Integral from A to C of the absolute value of v of t dt. If anyone can tell me what this is, I will give you a point. Integral from A to C of the absolute value of v of t dt. I'll give you a point if you...
9.
It's 9, so you guys get the point.
I had that too.
So it's 9 feet.
Nice done.
And the reason is because what's absolute value do? It takes everything beneath the x-axis and brings it above the x-axis. Takes everything that's negative and makes it positive, right guys?
Yeah.
So, here we go. This right here would really be up here and end up being a positive area. So you'd have 8 and you'd have 1, you would get 9, right? So here's the big takeaway, which we gotta write down and we have to know, have to understand. Integral from A to B of v of t dt is your displacement. I'm going to explain this a little more and I'll be done. Integral from A to B of the absolute value of v of t is your total distance traveled. Total distance. And let's talk about this. I'll let you write that down. All right. Guys, when we looked at this example, sorry, I'll bring it back in 1 second. When we integrated velocity from A to C, basically it's saying I went 8 feet forward and 1 foot backwards, right? So I went 8 feet forward, then I went 1 foot backwards, so I was 7 feet away from where I started at, right? Because I got 7. But when I integrated the absolute value of v of t from A to C, I said, how far did I travel? Well, I went 8 feet forward, 1 foot backwards. I traveled 9 feet, right? I traveled 9 feet. I was only 7 feet away from where I started, but the total distance I traveled is 9 feet. Herman, does that make sense?
Yeah.
Straightforward?
Yeah.
Sweet. Now go back. Guys, that is like one of the biggest things, but students trip it up all the time. Janelia, what's up?